Hello everyone, welcome back to Creative Civil Engineering Coach after so long time.
So in this session we will discuss about plastic moment, yield moment, load factor and shape factor. Coming to the plastic moment is defined as the internal bending moment at which an entire structural cross section becomes fully yielded, which is nothing but it is forming a plastic hinges. So plastic moment is defined as the product of plastic section modulus multiplied by yield stress. So it behaves as a constant restraining moment during the large rotation and allowing the structure to redistribute the loads. So in this picture you can observe with three different moment phases. So one is elastic stage, yielding stage, as well as the fully yielded plastic hinge stage.
So coming to the load factor in the plastic design. So load factor is the ratio of ultimate collapse load to the working load that can be applied to the structure. So load factor is the product of factor of safety multiplied by shape factor. So factor of safety at the member level largely depends upon the nature of loading, support conditions and mode of the failure. Here you can observe with the shape factor, it completely depends upon the geometry of the cross-sectional area. So next we will discuss about the shape factor. So shape factor is defined as the ratio of plastic moment to the yield moment, or the ratio of the plastic section modulus to the elastic section modulus. So here in this picture you can observe with the formula given here, shape factor, which is represented by the letter S, it is the ratio of plastic moment MP divided by yield moment My. It is also equivalent to the plastic section modulus ZP divided by elastic section modulus Z. So now let's discuss some of the important key points related to this shape factor concept. So obviously the shape factor is a dimensionless, so it gives the exact mathematical value depending upon the geometrical cross section. It depends upon the geometry of the cross section and not the material. Higher the shape factor, greater is the section's ability to withstand the moment beyond its first yield capacity. So shape factor indicates how much the additional moment capacity is available after the first yield. Greater the shape factor, greater will be the reserve strength as well as ductility. So as we discussed earlier, shape factor is the ratio of plastic moment to the yield moment, where plastic moment is defined as the moment when entire section is fully yielded or plastic hinges formed. It acts as a constant restraining moment during the large rotation. And the yield moment is defined as the moment at first yield of the extreme fibers where the section behaves elastically. So here in this picture some of the common geometrical shape factor is given. So here you can observe a rectangular section has a shape factor of 1.5. A standard I section is having a shape factor of 1.15 and a circular solid section is having a shape factor of 1.7.